Okay, so page 85. There's really nothing new in this lesson except how the information looks. Okay? They're giving us the information on a table instead of a double number line or instead of in a sentence. And then they're going to ask us to find another set of numbers from that table. Okay, so a recipe for trail mix says mix 7 ounces of almonds with 5 ounces of raisins. Notice the first entry on the table. The first entry on the table is telling us we have 7 ounces of almonds and 5 ounces of raisins. Okay, before we would have put that as our first entry, well, second, because we start with 0, 0, on a double number line, we would have had 7, 5, and then we would have labeled this one almonds and this one raisins. Okay, same thing, it just looks different. Here is a table that has been started to show how many ounces of almonds and raisins would be in different sized batches of this trail mix. If they give us one full set, we should be able to fill in anything else if they give us at least one. By looking at the relationship, take this. So complete the table so that the ratios represented by each row are equivalent. If on here they gave us 28 ounces, what could we do to find that number? If they gave us 28, let me make that in black so it stands out a little bit more. If they gave us 28 there, how could I find the box, Leo?
Since 7 and 5 are your ones, you can just multiply 7 by whatever.
Yeah, I can find the multiplier. What's 7 times what equals 28?
4.
4, so times 4. So I do the exact same thing on bottom. Dom, what's 5 times 4? 20, okay? So table, you do the exact same thing, we just show it a little bit different. We're going to show our loops right here. How do we get from 7 to 28? Times 4. And on the other side, those loops have to go from the start. They have to start at the same spot and end at the same spot. So we started at the top one. We ended on the second one. I'm going to draw the arrows just showing that we're going that way. How do I get, or what's 5 times 4? 20. Leah. Yes, a table could also be horizontal. So this is a vertical table. We could have also drawn it, yes, pretty much even more like a double number line. Yep. Almonds, raisins would be there, and then the numbers would go up and down. So this would be 7, that would be 5, 28, and 20. Okay, and typically in a table the numbers are in order, but they don't have to be. They should be, but sometimes they put them out of order to try and screw you up. And they don't always do every entry. Like if I did, like they went from 1 batch to 4 batches. They didn't do 2 and 3 in there. So it's not always 2 batches, 3 batches, 4 batches, 5 batches. They might do 2 batches, 5 batches, 10 batches. So always start with what your one full set and build off of that. So for the third entry, we're going to show it 2 different ways, and you won't have to do it 2 ways. I'm just showing you we can. For first one, we're going to start from the 20, because see how that's now a full set. I have it completely filled in, so I can build off of that one. So I'm going to go from 20 to 10. Meyer, how do I get from 20 to 10? Think about that. From 20 to 10. Divide by 2. What could I multiply by that's the same as dividing by 2? Leo? Times 1/2. I'm going to write that in parentheses, just so you keep seeing it. Dividing by 2 and multiplying by 1/2 is the same. You guys are writing this. You're doing this with me. So on the other side, if I went from here to there, I have to go from 28 to here. If I divided by 2 on the right side, I have to divide by 2 on the left. Oh, and what's 28 divided by 2? 14. Who thinks they know another way I could have found 14 right there? Leo? Or, okay, 28 times 1/2. Ellie?
You could see that from 7, the first ratio, you could take
Yeah, you can use any full set to build up to where you're going. So I could have gone, I'm just going to draw this out on the outside even further. I could have gone from here to here. You just have to think about, how do I get from 5 to 10? Times 2. And then do the same thing on the other side. I started at the top and I went to the third one. So I have to start at the top and go to the third one. So 7 times 2, would we have gotten the same answer? Yes. So usually there's more than one way to get to where we're going. Next one, 3.5. Now we have 3 options. So let's look at the numbers we're given. We're trying to get either 7, 28, or 14 to 3.5. Who thinks they know which one of those I could get to 3.5? Afton, what do you think? Because I have to try and get one of these 3, because these are my 3 filled in. So I have to try and get one of these to that. Okay, 7 would probably be the easiest. How can I get from 7 to 3.5, Afton? Divide it by 2. So let's show that. And again, your loops are going to get kind of crazy, but I want to see the loops. So I'm going from here to here. To get from 7 to 3.5, she's saying I can divide by 2. So on the other side, I go from 5 to there. And what math do I need to do? Divide by 2. Or think, what is half of 5? Dawson, what's half of 5? 2.5. If you do not know that, could you go out to the side and take 5 divided by 2? Yes, 2 goes into 5 2 times. I add my decimal point and my 0. 2 goes into 10 5 times. Okay? Now we're trying to get raisins to 250. Emmy, which of those numbers is easiest to get all the way up to 250? 10? Okay, so I'm going to show a loop from 10 to 250. Emmy, 10 times what equals 250? So times 25. So then on the other side, I have to do 14 times 25. Do most of us know that? How could we use mental math? Or what could we use? Hallie? Okay, you could have used the 2.5 to get there, to do a different, but how can we turn 14 times 25 into a mental math problem? What can we think about that we're all familiar with? Ellie?
You could break it down into 4 times 5 plus.
You could. Think money.
No, it would not be $14.
It'd be 14 what, Afton?
14
14 quarters. Could we figure out how many cents we have if we have 14 quarters?
Yes.
If it's faster for you to just go out to the side and do 25 times 14, go out to the side and do 25 times 14.
25.
So 25, 50, 75, $1.
So just count.
25, 50, 75, $2. 25, 50, 75, $3. That's 12. And I have 2 more. So 25, 50. So 350. So is it 3.50?
No, it's 350.
It's 350. Yes, 350. And again, if you can't do that, can you go out to the side and take 25 times 14? Yes, I'm trying to develop your number sense. I know you guys can all count quarters. I see you at the concession stand. Okay? Apply what you know about money to this class, and it will make some of these problems easier. Yeah, you could have multiplied by what? Yep, multiplied by 100 there. So she's saying we could have multiplied this one by 100, that one by 100. We still would have got the same answer. 56. Aubrey, which of those numbers is easiest to get to 56? 7. 7 times what equals 56?
8.
Times 8. So then on this side, I have to take 5 times 8, which is, anybody?
40.
40. when you do these problems, you should have lots of loops out to the side.
Mine just looks like
Yours might look a little bit neater than mine. What a lot of students do, I'll let everybody get that and then I'll clear it. Anybody still copying that?
Is that how we'll do it then?
Yeah, I want to see your multipliers. You're showing me what your because if you miss it, that's probably where you messed up. But if you miss it, I want you to know, oh, I multiplied by 2 and I should have multiplied by 3. Okay, because that's one of the possible errors. The other one is you multiply incorrectly. Okay, so I'm going to clear this to keep this neater.
So could it, like, you can just skip from, like, you go from this to a high number then back to a low number? It's not like
Usually they're in order, but like see how this one's not in order.
Yeah.
And sometimes they give you like 7, 14, 21, 350. So they don't go one by one. Usually on a number line, it goes one batch at a time. So tables are used more often when you're skipping batches in the middle. But number lines could technically skip also, as long as the numbers that go together are lined up vertically. So to keep your loops a little bit cleaner, what a lot of students do is they write the multiplier down here. So they'd write like times 4 right in their answer. And then for the next one, they just write it a little bit, what was that, times 2? So times 2
If you think about it,
times 2.
Like, you'd have huge loops at the end of that.
Well, I mean, that's where they would kind of overlap their loops a little bit and just write the multiplier like down at the bottom.
Multiplier clearly.
Yes, but the lines kind of overlap a little. Okay, so the question, did we complete the table so that the ratios represent, okay, we did that. Number 2, what methods did we use? We did multiplication and division. How do you know that each row shows a ratio that is equivalent to 7 to 5? How do we know if we did our math correctly? Owen?
we just multiplied, like, if we did 7 times 4, we did 5 times 4.
Yeah, what would all of them reduce to?
7 and this.
Yeah, all of the ratios in the table would reduce to 7 to 5. That's our reasoning. All of the ratios would reduce to 7 to 5. Did you get that done? Once you have that written, flip over to practice problem number 1. I think you have to turn to page 87. Okay, I'm going to get there in just a sec. Maybe. Oop. Is it like bouncing? Okay. Practice problem number 1 says, complete the table to show the amounts of yellow and red paint needed for different sized batches of the same shade of orange paint. Explain how you know these amounts of yellow paint and red paint will make the same shade of orange as the mixture in the first row. There's nothing. What does that mean?
Fill it in.
Yeah, you have to fill it in, but you have to make sure they're all equivalent to what?
5, 6.
5 to 6. Everybody in here could have different answers here and they could all be correct. Are there wrong answers?
Yes.
Yes. Elise, pick a multiplier. Times 5. So we're going to do 5 batches of this paint first, but we're going to show times 5. Times 5. Dom, what would 5 batches of this paint look like? How much yellow, how much red?
25 yellow and 30 red.
Okay, 25 yellow and 30 red. Leah, pick a multiplier. And again, guys, you're getting to choose. Keep it simple. Okay, don't make your life too difficult. Times 3. Could I have built off the 25 to 30?
Yes.
If I wanted to, yes. And she didn't specify, so I went off the top one. Now, my suggestion, if you can, try and build off the given information. Why do you think I'm going to suggest that? Try and build off what is given to you. Hallie?
Because then it's more likely that you'll get it right because you got it from the
Yes. Raise your hand if you're perfect. Okay? If we messed up, if we made a goofy mathematical mistake to get this answer and then we build off of that, is there any way our next one can be correct?
Unless you miss it really bad.
Yes. Yeah, unless you mess up so much you happen to get lucky and wind your way back to correctness. Usually that doesn't happen. Now, in that last problem, there were some where it was really hard to build off the original. But always look there first. Look at the original and see if you can easily build off of it. If not, then look at your other options and just hope that you didn't mess them up. Okay, so then this one would be 15 to what? 15 to 18. Dom, pick a multiplier. 6. I'm going to just go off the 5. What would that one be, Meyer? If we did times 6. 30 to 36. Okay, so we filled in the table with equivalent ratios. Now, how do we know that these would make the same color of orange paint? Leo?
You can take them all and divide them if they equal 5, 6, 3.
Yeah, so they would all reduce to, yep, they all reduce to 5 to 6. So what's the difference in them? If they all reduce to 5 to 6, what's different about them, Ellie?
It's like some of them make more.
Yeah, it's just some of them make a larger amount of the orange paint. It's all the same orange paint. How many quarts would the blue set make? How many quarts of orange paint would my blue set make up there? How could I figure that out? How much orange paint would I get from those blue set of numbers? Leo?
Is it your multiplier?
Nope, it's not my that means it's just going to make 3 batches. But if I said, how much orange paint am I getting? We should be able to answer that. We just have to think about it. Tatum? 33 quarts. Why?
Because 15 is the amount of quarts and 18 is another amount of quarts.
Yeah, if I put in 15 quarts of yellow paint and 18 quarts of red paint, I now have a new color, but did any of the quarts, do they evaporate?
No.
When I stir them, do they go away?
No.
No, they mix colors. On some of the problems Friday, those were the ones you had trouble with because we haven't had those kinds of problems yet, but they're coming. Where it would say, like it could give us the 5 to 6 and it might say, if I have 33 quarts of orange paint, how much yellow was used? Okay, that's where we're going in lesson 15. Okay, let's look at number 2. A car travels at a constant speed. What does that mean?
It's doesn't slow down.
Yep, it's on cruise control. It's not speeding up, it's not slowing down. It's staying at the same speed. As shown in the double number line, how far does the car travel in 14 hours? Is 14 hours on my double number line? No, but we can now treat it like a table. I want 14 hours, so I'm going to just put a 14 and skip to it. So I need what matches with 14. What work can I show to skip to 14, Lily? So I'm looking at the 1, 2, and 3. Which one's easy to get to 14? Okay. How do I get from 1 to 14? Times 14. And then what would I have to do on bottom? Yeah, I'd have to do the same with 70. Oops, I wrote times 4. Times 14. I'm going to do 14 times 7 and add a what? 0. A 0. I'm just going to put it out there. 4 times 7 is 28. Could I have gone from 2 to 14?
Yeah.
How do I get from 2 to 14?
Times 7.
Times 7, if I look, I would have had to do 140 times 7, which is really still the same. So, how far can a car travel in 14 hours? What's my answer? 980 kilometers. Our reasoning is our work. We showed our work over there. Look at example 3, or practice problem 3. The olive trees in an orchard produce 3,000 pounds of olives each year. It takes 20 pounds of olives, so 20 pounds of olives to make 3 liters of olive oil. So put that on our table. 20 pounds of olives to make 3 liters of olive oil. How many liters of olive oil can this orchard produce in a year? If you get stuck, consider using the table. What do I need? So it wants to know how much olive oil in a year. How many liters of olive oil in a year? And all we know is pounds and liters. So we're looking for this column. We're looking for how many liters. How can I figure out the number of olives? Or what do I need to know about the number of olives? Ellie?
Since we know that they make 3,000 pounds of olives in a year, we just need to know how many.
Yeah, it told me right here they make 3,000 pounds of olives in a year. This says how much olive oil in a year. So if I know this is 3,000, this is the one that I'm looking for. On a table, you can build it up to anything. How could we, let's go how they went first. Why do you think they went from 20 to 100?
Because 20 is easy to get to 100.
20 is easy to get to 100. What times 20 equals 100? 4 quarters and $1. Times 5. Okay, so times 5. We'll just build it up. Times 5. So they're building it up to get to 3,000. 3 times 5 is 15. How do I get, so let's just look at our mental math. 1 times what equals 3? 3. And then there were 2 zeros in our problem, and there were 3 zeros in our answer. So how many in the rest of my problem? 1. Could we have used that same logic from the beginning? 2 times what equals 30, and then figure out how many zeros we need? So on this side, we have to do 15 times 30. Let's do it mentally. What's 15 times 3?
45.
45. 15 times 3. I'm going from, we built it up to 100, so we're doing one loop at a time. And then how many zeros do I need behind that? 1, because I only had 1 zero in my problem. 15 times 30. A table is not your answer. A table is your work. So how many liters of olive oil can they make in a year? 450 liters. Once you have that, turn the page. And we're actually going to stop there. Okay? Your homework tonight is to take notes. What do you think you're going to take notes over? I know your favorite, Dom, Mr. Morgan. Turn your book to page 91. Turn your book to page 91. So you're doing lesson 12 notes. You will start at the beginning. Okay, so you'll start at the beginning of the video. It's lesson 12. Those are right there. Okay, so you're going to start at the beginning. Turn to page 94. Okay, Okay, so you're going to start there. You're going to go to page 94, which is this. Is that the top of page 94?
Yep.
Okay, and you will stop right here. You will stop before he goes on to the Are You Ready? So on page 94, you will stop before the Are You Ready? It's right at around 15 minutes. Okay, I can't remember if it's just over or just under, but it's right around the 15-minute mark. Questions on what you're doing? Okay.
So this and this.
So you start at the beginning of the video, which is here.
Okay.
So page 91 through the top of 94. Okay, and again, it's right around 15 minutes, and you guys have the rest of the time to start on that video. If you need to go grab headphones, you may. About 12 minutes.